From asteroids capable of destroying entire species to gamma ray bursts and supernova that could exterminate life on Earth, outer space has no shortage of forces that could wreak havoc on our tiny planet. But there's something in space that seems more terrifying than any of these. Something that wipes out everything it comes near. Could the Earth be swallowed by a black hole? A black hole is an object so dense that space and time around it are inescapably modified, warped into an infinite sink. Nothing, not even light, can move fast enough to escape a black hole's gravitational pull. Once it passes a certain boundary known as an event horizon, thus, a black hole is like a cosmic vacuum cleaner with an infinite capacity, gobbling up everything in its path and letting nothing out. To determine whether a black hole could swallow the Earth, we first have to figure out where they are. But since they don't emit light, how is that possible? Fortunately, we are able to observe their effect on the space around them. When matter approaches a black hole, the immense gravitational field accelerates it to high speed. This emits an enormous amount of light, and for objects too far away to be sucked in, the massive gravitational force still affects their orbits. If we observe several stars orbiting around an apparently empty point, a black hole could be leading the dance. Similarly, light that passes close enough to an event horizon will be deflected into a phenomenon known as a gravitational pull. Most of the black holes that we have found can be thought as two main types. The smaller ones, called stellar mass black holes, have a mass up to 10 times larger than that of our Sun. They are formed when a massive star consumes all its nuclear fuel and its core collapses. We have observed several of these objects as close as 3,000 light years away, and there could be up to 100 million small black holes just in the Milky Way galaxy. So should we be worried? Probably not. Despite their large mass, stellar black holes only have a radius of around 300 kilometers or less, making the chances of a direct hit with a mini circuit. Although, because their gravitational fields can affect a planet from a large distance, they could be dangerous even without a direct collision. If a typical stellar mass black hole were able to pass in the region of Neptune, the orbit of Earth would be considerably modified, with dire result.